Hello everyone, myself Ankur Agrawal here to solve your doubts. And here is a problem from the chapter Chemical Bonding. So the question is, in which of the following processes the bond order has increased and paramagnetic character has changed to dimagnetic? So you have to predict in the question that in which of the following given option the bond order has increased and paramagnetic character has changed to dimagnetic. So you have to observe each and every option. I am going to tell you a trick also how to calculate bond order, okay, without drawing molecular orbital diagrams. Okay, so here what you have to do is you have to just draw the molecular orbital diagrams. For example, 1s bonding and anti-bonding. Okay, so firstly we are drawing this for oxygen O2. In case of O2, the configuration of oxygen is 1s2, 2s2, 2p4. So 1s2, 1s2, they will overlap 1, 2, 1, 2. Okay. Similarly, 2s2, 2s2. So this will be. Next is 2p4. So it is like this. So these are completely filled, initially 6 orbitals. And next to 2 orbitals, here 2 unpaired electrons are present. That's why O2 is paramagnetic in nature. So O2, which is paramagnetic in nature, having 16 electrons. And what is bond order? How to calculate the bond order? Bond order can be calculated by just to subtract the number of electrons present in bonding orbitals minus number of electrons present in anti-bonding orbitals divided by 2. So number of electrons present in 1s2, 2s2 will get cancelled. So there is no meaning of counting them. So bonding and anti-bonding you have to subtract here. So in the bonding orbital there are 6 electrons and in the anti-bonding there are 2. Divided by 2 you will get here 2. Okay. So for O2 the bond order is 2. So paramagnetic having bond order 2 getting converted into, similarly if you will do for O2 positive, 1 electron will become lesser here. So here it will be 1 and it will be 2.5. So total number of electrons is 15 electrons here, 16 electrons are present, 15 electrons are present here, and it is also paramagnetic in nature, and bond order is 2.5. Bond order is 2.5 for O2 positive. Similarly, O2 to O2 negative, you can check. So nature is not getting changed here. So first option gets cancelled. In the C option also, O2 is having 16 electron. It is paramagnetic in nature, and the bond order is 2. For O2 2 negative, for O2 2 negative, you will fill these electrons also, and then 1 electron here you will fill, and next electron here. Okay. So the number of electrons in anti-bonding is 6 minus 4 divided by 2. You will get 1 here. Okay. So for O2 2 negative, you will be getting the bond order is 1. So total number of electrons is 16. The nature is diamagnetic and number of electrons is 1. So the nature is changing from paramagnetic to diamagnetic, and bond order but has not increased. Bond order here has been decreased. So this option also get cancelled because bond order here has decreased, got changed, but it's decreasing from N2 to N2 positive. N2, I hope all you know, nitrogen. The configuration of nitrogen is 1s2, 2s2, 2p3. So 1s2, you can draw here. So 1s2, 2s2, 2p3. This is the configuration of one nitrogen atom. 1s2, 2s2, 2p3. This is the configuration of another nitrogen atom. Now you have to just put them in bonding and anti-bonding molecular orbitals respectively. Now 1, 2, 3, 4, 5, and 6. Okay, in this way 6 electrons will be filled here. So number of electrons present in, so 1s and 2s will get cancelled. Number of electrons present in anti-bonding is 0 and bonding is 6. So 6 minus 0, bonding minus anti-bonding, 6 minus 0 divided by 2, that is 3. So bond order for nitrogen, total number of electrons is 14, and it is you can observe dimagnetic in nature, and the bond order will be 3. For N2 positive, 1 electron will be lesser here, so this will be 5 minus 0 by 2, this will be 2.5. That will be the bond order for N2 positive. So that is 13 paramagnetic and 13 paramagnetic in nature, and as well as the bond order is 2.5. So here also bond order being decreased. Bond order being decreased. It is saying in which of the following bond order is increased and paramagnetic nature has changed to diamagnetic, and it is also from diamagnetic to paramagnetic. So this option also gets cancelled. Automatically the answer must be the D. Now let us check NO and NO positive. Say here I am placing nitrogen and here oxygen. Okay. So total number of electrons you can count is 15. Total number of electrons you can count is 15. So nitrogen is having 1s, they are having fully filled. 2s, they are having half filled. So 1s2, 2s2, 2p4, and here it is 1s2, 2s2, 2p3. Okay, but 1 electron less you have to fill. Say it is in the oxygen. So 1s, for 1s you will fill like 2 electrons in the anti-bonding and 2 in the bonding. Similarly, anti-bonding, bonding, and here 1, 2, 3, 4, and 5, 6. So NO positive is, NO is dimagnetic in nature. NO positive is paramagnetic in nature. NO is paramagnetic in nature. सबसे पहले NO का draw करो. Firstly, we have to draw the structure of NO. So while drawing the structure of NO is here paramagnetic in nature. You can see total number of electrons here is 15. Total number of electrons here is 15. Paramagnetic in nature, and bond order is number of electrons present in bonding molecular orbital minus number of electrons present in anti-bonding molecular orbital. In the bonding, it is 1, 2, 3, 4, 5, 6, 6 minus 1 divided by 2, that is 2.5. 1s, 2s electrons I have not considered here because they will get cancelled. 2 minus 2, 0, 2 minus 2, 0. So 6 minus 1 by 2, that is 2.5. So now let us calculate for NO positive. So total number of electrons is 50. Okay. So 1 electron will get lesser here simply. So it will be dimagnetic in nature. So it is getting total number of electrons is 14. It is dimagnetic. Here the bond order was 2.5. Here the bond order will be 3. So bond order as well as is increased, and it also changed from paramagnetic to dimagnetic. So the correct answer is option number D. One more thing, bond order for calculating the bond order, I am going. I said that I will tell you a trick. So for 14, you just calculate the total number of electrons for the given atom. Say N2, NO, whatever. Say total number of electrons is 14. In NO positive it is 14. In N2 it is 14. So for them the bond order is 3. Now for 15 it is 2.5. For 16 electrons it is 2. For 17 electrons it is 1.5. For 18 electrons it is 1. Similarly, you can go here. For 13 electrons it is 2.5. For 12 electrons it is 2. For 11 electrons it is 1.5. For 10 electrons it is 1. And in this way you can calculate the bond order for the given species. Okay, so this is the way you can do these kind of questions and predict the nature of the compound as well. So you must have clarity in your mind for the atomic orbital diagrams, and if you are not having, you can do this by trick also. Okay, so this also helps a lot in exams, so you can remember this. So that's all for this question. I hope you got the correct answer as well as you understood the concept as well. So thank you very much.